This is a pre-built version of the application. So if we go ahead and run it, and the goal is that given some course scheduling supplied data, we need to use genetic algorithm in order to find a university class schedule with no conflicts. So here we started from generation 0, where we had the fittest schedule had 4 conflicts. And this is a table representation of that fittest schedule. And we went to generation 10, where we found this fittest schedule with 0 conflicts. And the schedules in the population are sorted by fitness. So this one is the fittest, and this is the table representation of that. And a conflict can be one of 3 things for this simple application. It can be an instructor assigned to teach more than one course at the same time. It can also be a room occupied by more than one course at the same time. Or it can be a course assigned to be taught in a room with a seating capacity that is smaller than the course maximum number of students. And if we go back to generation 0, let's try to find the 4 conflicts here. So one of the conflicts is that James Webb is assigned to teach those 2 classes at the same time on Monday, Wednesday, Friday. And another conflict is that the maximum number of students for this course is bigger than the room seating capacity. And another conflict is that room 2 has those 2 classes scheduled at the same time, Monday, Wednesday, Friday, from 9 to 10. And another conflict is that room 1 is scheduled for 2 classes at the same time. So this class on Monday, Wednesday, Friday from 10 to 11, and this class on the same date and time. And the data supplied here is very simple. So we have 3 departments, a math and a double E and a physics. The math has 2 courses available, and the double E has 3, and the physics has 2. So we have 7 courses in the system, and those are the maximum number of students for each one of those courses, and those are the instructors that are qualified to teach each one of those. And we have 3 rooms, and those are the maximum seating capacity for each one of those rooms. And we have 4 instructors and 4 meeting times, Monday, Wednesday, Friday from 9 to 10 and from 10 to 11, and Tuesday, Thursday from 9 to 10:30 and from 10:30 to 12. I will start by creating a new Python file. And here we will have a data class that will contain and initialize the data, and a population class that represents a population of schedules, and a genetic algorithm class that evolves the population from one generation to the next using crossover, mutation, and elitism. And we will have a course class representing a course to be scheduled, and a course instructor class. And a room class where the course will be taught, and a course MeetingTime class, and a department class. And a class representing a course with a specific department that is scheduled to be taught by a specific instructor in a specific meeting time and in a specific room. And finally, we need a schedule class. Now a course will have a course number and the course name and the max number of students and instructors that are qualified to teach this course, and we will initialize those values in the constructor, and we'll have get methods that returns them, and a toString method that returns the name of this course. And a department will have a name and courses that it offers, and we initialize both of them in the constructor, and we have get methods for both. And an instructor will have an ID and a name, and they are both initialized in the constructor, and get methods for both, and the toString method returns the name of this instructor. And the meeting time will have an ID and a meeting time, and they are both initialized in the constructor, and get methods for both. And the room will have a number and a max seating capacity, and they are both initialized in the constructor, and they have get methods that returns them. And a class will have an ID and a department that it belongs to, and a course, and those are initialized in the constructor, and we set the instructor and the meeting time and the room for the class using those three methods, and we have get methods for everything here. And the toString method returns the name of the department and the course number and the room number and the instructor ID and the meeting time ID separated by commas. Now the data class will have rooms and meeting times and instructors and courses and departments, and it will keep track of the number of classes in the system, and we have get methods for all of those. Now for the purpose of this tutorial, I have this data coming from here, and I'll have it coming from a database in a future tutorial. And here we will pick up an instance of the data class, and the schedule will use that, and here we will have the classes for this schedule instance, and the number of conflicts, and the fitness, and a class number counter that we will use here in the initialize method. So we use data to pick up all the departments, and we pick up the courses in each department, and for each course we instantiate a new class passing in the class number counter and the department and the course. And here we increase the counter, and we randomly set the meeting time to one of the meeting times in data, and we do the same for room and for instructor. So here we pick up one of the qualified instructors for this course, and we put the new class instance in the classes in this schedule, and we return the schedule instance, and we will have get methods for the classes and the number of conflicts and the fitness for this schedule. And this method will calculate and return the fitness, so here if the number of conflicts is 0, then we will have 1 over 1, so we will return a fitness of 1, and we add 1 to the number of conflicts in 3 cases here. So if the room seating capacity is smaller than the course max number of students, and if the room is scheduled for more than one class at the same meeting time, and if the instructor is scheduled to teach more than one class at the same meeting time. And finally we have the toString method that returns all the classes in this schedule separated by commas. And if we go to class, each class will be the department name and the course number and room number and instructor ID and meeting time separated by commas. And now for the schedule population. So this is the size of the population, and this is the population schedules, and we have get method for that. And given the size of the population, we instantiate the schedules and call initialize method on each and put them in schedules. And let's add this DisplayMgr class. That prints the department and the course and the instructor and the room and the meeting time. And this prints the generation, and this one the schedule as a table. And let's define this population size. That we will use here when instantiating the population. And this code sorts the schedule and the population, and this will print generation 0 and the fittest schedule in that generation in table format. And before writing the code for the genetic algorithm, let's go ahead and test run the application. So line 83. Okay. Okay, let's try it again. Okay, so let's go up here and add those two. So we are using this to display the data in table format. So now if we do Control Shift B to run it, here we go. So we have 3 departments and 7 courses, 3 rooms, and 4 instructors, and 4 meeting times. And this is generation 0. So the fittest schedule here has 4 conflicts, and this is a table representation of that. And this method here does crossover on all schedules in the population, and it uses tournament selection in order to select 2 schedules to do crossover on. And this method does crossover of 2 schedules that were selected here, and returns a crossed over schedule. And this method does mutation of all schedules in the population, and it will end up calling this mutate schedule on each one of the schedules, and we will have this public method evolve that ends up calling crossover population, and then calls mutate population on what is returned from this, and returns evolved population. And let's define here the number of elite schedules and the tournament selection size that will be used by this method, and the mutation rate. And here we will have this crossover population and return it, but before doing that, we will append the elite schedules without changing them. So number of elite schedules, we only have 1. So the one with the highest fitness. And for the remaining schedules, we will do tournament selection and pick up the fittest schedule from that, and this would be schedule 1, and then we would do tournament selection again and pick up the fittest schedule from that, and this would be schedule 2. And we will do a crossover on those 2 schedules and add the resulting schedule to the crossover population. And this skips the elite schedule and does mutations on the rest of the schedules. And this method does crossover on 2 schedules, 1 and 2, and returns a crossover schedule. So depending on the random value, we pick up classes from either schedule 1 or schedule 2. And this method mutates the passed in schedule before returning it. So if the random number is smaller or equal to the mutation rate, then we do mutation. And we pick up classes from this newly created schedule. And this should not happen often, so the mutation rate is a small number. And this code does tournament selection. So we pick up 3 schedules and sort them and return that population of sorted 3 schedules. And finally, let's go ahead and add this code here, where we evolve the population from one generation to the next until we get to a population where the fittest schedule has 0 conflicts. And finally, let's go ahead and test run the application. So we did 5 generation. We went from generation 0, where the fittest schedule had 2 conflicts, and we went to generation 5, where the fittest schedule had 0 conflicts. And this is a table representation of that. So Mike Brown has 3 classes to teach on Tuesday, Thursday from 9 to 10:30, and from 10:30 to 12, and on Monday, Wednesday, Friday from 10 to 11. And James Webb has 1 class, and Jane Doe has also 1 class, and Steve Day has 2 classes, one on Tuesday, Thursday, and the other one on Monday, Wednesday, Friday. And room 3 has 3 classes scheduled to be taught in it. So 2 on Monday, Wednesday, Friday, one from 9 to 10 and the other from 10 to 11, and one on Tuesday, Thursday. And room 2 has 4 classes scheduled to be taught in it. 2 on Tuesday, Thursday from 9 to 10:30 and from 10:30 to 12, and 2 on Monday, Wednesday, Friday from 9 to 10 and from 10 to 11. And here all the maximum number of students for each one of the courses is smaller than the room seating capacity for that course, smaller or equal.